FIY. My name is Shankar in Kerala. So thank you, SreeKumar, for inviting me here for the session for 3D printing for hams. I'm assistant professor of a college, and I have a company called Cure Labs, where I'm chief technical lab officer as well. And I'm volunteering for the ham as well as for IEEE Kerala section. I hope I'm audible enough. So kindly let me know through the message as well. So the main purpose of the session. Actually, I can hear one person saying it's not there. So for everyone else, am I audible enough? Okay. Thank you. So thank you all. So let's just start the session. So before we begin, let me say the purpose of this webinar series, especially for hams. So while I was starting, I recently got my license, and before that I was nearly 2.5 years as SWL. So while starting with home brewing, like it was found that we are not unable to get the correct size components for completing our circuits or to have an enclosure of a particular thing. So being an engineer and being assistant professor, like we already have the 3D printing as additive manufacturing technology where we can construct each things. So according to our ham application, we can do as well. So in this session, what we'll cover is, especially for hams, how we can use this latest 3D printing technology for implementing that as well. So here we will cover the basic things where you don't need to know the 3D modeling, but I will cover a basic software which is used for that. And then we will see like how to download the required file for 3D printing as well. And after that, which are the centers that we can give those 3D printing materials to have the 3D print for our application. So if you see by using 3D printing, the cost of buying the particular component and manufacturing is, when you see that, it's quite cost effective when you are using 3D printing. So that is a beauty of it, especially for the home brewers. So I hope the introduction session is clear, I guess. So the main objective of the session is clear as well, I guess. So let's move on with the slides so that each and everyone knows that. So this is the main thing. So after the participants will be know the additive thing, mainly the 3D printer is operation. And what we are going to do is that we will be working. I hope you can see my mouse as well. We'll work with a software called Cura, where it is specifically designed for 3D printers, which is named as Ultimaker 3D printer. So there, what we can do that is, the 3D printer that we use is Ultimaker 3.0. We have a different version as well. So in mostly, if you know, in Make in India scheme, like I believe we have other participants from other states as well. So that's why I'm continuing in English. So under the Make in India scheme and Startup India, we have Kerala Startup, and we have different like Chennai Startup, Meta Startup. So each state has a different startup as well. So what we can do is that uh, we can approach them for implementing our 3D printing model. So the main idea is to know the basic software which is used by the startup, especially that supports. If you we say that it's a Kerala startup mission, so we have different fabrication laboratories overall Kerala as well as in each state we have fab labs or fabrication laboratory. So I hope a few of them are saying something is went wrong. So audio is not there, I guess. But in my profile, the audio is still working. So let me know if others have the same problem as well. Okay. Thank you, SreeKumar. So here, this is a main objective that we are looking for with working with the Cura, and the C, if possible, like I can show you the prototypes that we have. So I have, since we can't hands-on field experience, I have put few photographs in the 3D printing models I have already built. So let's move on. So when we say, as you all know, that we are already taking printer, we have used at least a printer for printing paper. Similarly, if you think, we can classify into 3 steps, where but here the printing happens on only the 3D object that we are going to print, not a single paper of paper. So what we can see is that if you print 1,000 pages, you can see, when you align 1,000 pages, you can see that as 1,000 paper, 1,000 layers. So if you cut each paper in each layers, finally you will have a 3D object. So let us consider this first object. I hope you can see the mouse. So this is a first 3D object that we are going to print. So what we will do is we will model or design this 3D object into a software 3D model. So actually, if you have a particular model of a phone, like say, if you are going to print a phone case. So here, what we'll have, we will design a phone case exactly to the specification match for our phone. So we will create a 3D model. What we will do is that we will use this 3D model software to do that 3D modeling, and we will convert this 3D model into different layers. You can see each layers, this 3D model is being converted to each layers. So what we will do is we use a software to create a 3D model, then we will convert this 3D model file to different layers, which is fed to the printer. So the printer identifies how many layers it has to print. So the 3D model has to be converted to a knowledge to the printer, 3D printer, where the printer should identify, okay, how many layers I need to print that layer, and for each layer, what is the dimension required. So the finally stage is the Ultimaker, which is a 3D printer, print those layers. So this layers information will be printed by a software called Cura. So let us consider a regular printer. Say like you have a HP printer or a Canon printer. So where what we will do is that in the first section, what you will do is that you will use Windows, maybe Word file, or open source or ORG files, where you will type the required document here. Let's say there's a letter or a photograph here. So first we have, instead of this 3D printer, when you're comparing with the ordinary printer you have already felt, just let me have an analogy as well, so that you will know the comparison of what is 3D printing one and what is the ordinary printing. So in ordinary printing, what we'll have is, we will have a regular Word document. So this is actually a Word document. So what it happens is the Word document will be analyzed by the, we are going to print, let's say there's a Canon printer. So this Canon printer is there. So this Canon printer will identify this Word document, and it directly prints that particular page according to the specification of the printer profile, where we want to use color printer, color cartridges or black cartridge, whether we want to do it very fast or very slow with the resolution. So these printer settings will be done here. So let me repeat here. We will say the Word document, and Word document will be converted to the required specification for the printer to use, maybe high resolution or low resolution, and that information will be used by the printer to print that particular Word document. Similarly, what we are going to do is that what we will create a 3-dimensional object in a software. So we can say the software is 123D. I will repeat, it's 123D software, which is actually a CAD software, computer aided design tool. We can call short form as CAD, computer aided design. So those software will enable us to draw 3D pictures, and 3D pictures will be converted to different layers, and that file format can be called as .stl files. That file format, in the sense that if you have a Windows doc format, we'll have doc .doc format. If you have a notepad, we call it as .txt format. So with those things, we can have that as well. So I hope in between the time, I'm just checking 3xe software as well. So if you have any further issues or not. So moving back to the PPT. So with that software STL file, that STL file will be given in a pen drive, and the pen drive will be plugged to the 3D printer Ultimaker, and the Ultimaker directly dictates the pen drive, because the pen drive that we purchase from the Ultimaker, when you purchase or procure Ultimaker, it has its own pen drive. So what we will do is, using that pen drive, we will copy those STL files converted by this Cura software, and this Cura software converts the 3D images to STL files, .stl files. So if you use any CAD software, since we have abundant usage of 3D printers, the common standardized format for 3D printing file is .stl format. So that is a point that I want to make it out, point it out, that for any 3D printing model, you need to have 3D printing files which is .stl file, so which is 3D compatible files. Those 3D files can be directly given to the 3D printer, and 3D printer prints right away what the file. So it identifies each layer as to what is the configuration, etc. So this is a basic idea of steps involved in 3D modeling. So today what we will cover is, we will know the basic CAD software that is used in the first section, and we will know how to manipulate or to work on the 3D printer software, that is Cura. So if you know these two, any person with any background can print a 3D model of their requirement. Suppose, let's say, I have seen and I have fascinated each hams going to Hamfest with their name tag on their chest with LED and all, and with the caps with their call sign. So the basic thing is that we already have a call sign, and we need to stick that call sign in front of the door or the laptop. What we can do is that we can have a small name plate of our call sign as well with 3D printing with any design. So that is one such application we can use there. So let me move on. So I hope these are the basic things of 3D printing idea. So just give a brief overview. This one such model. So before this is a model of one 3D printer I have. Okay, so this is actually a monoprice 133 select by 3D printer. It's actually very compactable one, which is of very it supports heavy duty, as well as it can be procured at home as well. You can get it for maybe 12,000 for that. So if you see, just I will briefly explain the structure of the 3D printer. So here you can see, I hope my mouse is visible. So here you can see a small display where the user can interact with the 3D printer. So we have a different setting as well. And here, this is actually the main post which supports the extruder. Extruder in the sense that it extrudes, or the materials that we use is commonly uses PLA. So that PLA is actually a kind of plastic material where it gets heated. The extruder heats that particular heater. So if you see that this is a closed overview, so it will be that if you see that can see a small white shaped material that is actually a PLA. So here in the third diagram you can see different spools, white, blue, brown, and golden, and here green. So these are the spools we can procure. So each spool may cost up to like 1,500. So it may, depending upon the weight, there may be 1 kilogram, 1,500. So actually quite cheap when you're considering it. When you are printing a particular small product, it may weigh only few grams, maybe 30 to 50. So that is actually quite high itself. That will be a big product of 50 grams, because being plastic is actually quite weightless. So this is extruder. So this spool will be fed over here, this side, where you can see this extruder, and here you can see a small BLDC, brushless DC motor fan, which same as that we use in laptop as well, or computer. This is of a smaller size to minimize the heat overall dissipated over the extruder. So here at the tip we have a nose where the PLC material is melted and poured down to the nozzle. So this is a basic structure of that, and below that you can see a plate, and here plate is already heated to a degree of 80 degrees. so that the PLA material sticks onto the surface and it doesn't move apart, so that the printing or the materials that extruder, when it moves for printing, it has accuracy where it moves on and prints the material. If this is not heated, there is a chance that the printed material may slip away and fall. So that may lead to the accuracy of the extruder falling one from point to another point. So usually this bed will be heated, and we can use a micro SD card or USB to copy the files. So you have a computer where you design them. So I hope this is clear till now. So any questions and all, I am able to say that. So few of them, the audio is not on. I hope if you able to reconnect it, I think you able to do that. So let me know if any questions are here till now. So otherwise we'll move on with the software as well. I hope still now it's okay, or am I slow? Okay, thank you all. Okay, so we will move on to the next slide. If you see the 3D printer parts, these are the few examples we have. So you can see the clamps, we can have the call sign or the numbers you can already print it. So this is actually the clamp and this is the clamp. So beauty of this 3D printer employed by Ham is that whatever materials you want to procure for like 500 or for 1000, because if you see a Morse Key, we need to spend quite amount if you have that. So, but if you print that particular Morse Key, it is actually quite cheaper because of the weight that we use. Because the 3D printing, if you do 3D print at a fab lab, it will cost you depending upon how much time you use that 3D printer and how many grams you use for the materials. So accordingly, it will may come around maybe 100 rupees maximum, because usually for 1 hour it's actually 35 rupees plus the charge of the grams as well. So I will come to in detail. So these are the 3D parts that we can use this. So here in the next session, I have downloaded few of the STL files which is used for printing this mosque. So with the connections of electrical parts or the other thing that we use as most is actually all 3D printed. So let me see and I can show you how it's been done in 3D model as well. So I hope we can switch on to that section. I hope it's okay for you all. We can move on to the software. Okay. Let me show you the software. So first I will show you the CAD software where I will place each component. So let me share my screen. I hope I am audible. Checking the file. Yes. I hope you can see the screen. So this is a software. I'm not sharing my entire desktop because it has full of all windows open. So I don't want to create a mess in the webinar as well. So I will share only the file is required. So this is actually a software for CAD, computer aided software. This is actually a free software where you can try it on. So if you see this, you can be, we can see there's a small cube over here. I hope my mouse is visible as well. This cube is actually, you can see the perspective view of your 3D printing model. So we can have a separate session on the CAD design of a 3D model. But here I will briefly elaborate what is the tool here so that you can manipulate the STL files that you are downloading from net. So this is a left view. If you see click this, it changes directly to the left. And if you click a home, it goes to the perspective view where you can see the 3D model assets. So if you, these are the options where you can draw a particular diagrams. Like you can see this box and sphere and all the diagrams going. So let me show you a particular thing. So I'm just placed a box here. So I'm putting on here. So here you can just see the 3D. It's a 3D model. The basic thing of having this software as well with you is that sometimes the STL file that you download from net won't be right away compatible for your set of application, as because the dimension that you use and the person use that the web will be totally different. So it is not advisable you to print that particular 3D model right away, because you need to identify the dimensions that the person has already designed and the dimension you require. So that is a main important thing that what I come to experience is that. So the beauty of this software is that it comes with the dimension inside as well. So if you have a STL file, first you can do is you can put right away at this particular screen and check whether it is meeting your required dimension. Because I had experience of downloading a file, and because of enthusiasm when I learned 3D printing in late 2016, what I did is I downloaded the file and directly printed it. But after the printed materials came, it was actually very small, where I can't even place one servo motor to control that. So that is a file I downloaded for a robot, especially a spider robot. So that is a main thing. So we often make mistakes, and with the mistake we improvise. So this is my suggestion to you all. So next thing is that after session, you will be able to download the STL files required from your set of application from your ham project, DIY project, do-it-yourself project. First thing I recommend is you download those files, put this Autodesk 123D design and check the dimension. Once it is okay, you then what you do is that you export this file as an STL file, or you can save this file. So what you can do is that you can just click here and a Windows open, and I'm going to save here. Where you can see is that it's a 123D model form. So these are the basic thing where you can do. So I will just close it, and I will talk about. I will try to copy an STL file I have. I have a Morse file. Let me check. So okay. So I hope you know this file, I guess. I hope you are able to appreciate what is this. Actually, it's a Morse key, that what we are going to press that key. I hope it is visible and it's okay, I guess. So this is actually the Morse key where you are going to press this button here so that it moves. So when you can see that this is already file available here. So if I look closely, if I place it here for your reference, this is my 0, and you can see that it it's in all millimeter. So you can see is that slightly above 7.5 here, it's coming here. But the total size is, if you see the cylinder, you can see the size as well. It is actually quite. Okay, let me see. If I see this side, top view side, okay, I can click here right as well. So you can see that this is my file size. So you can measure it right away using this software. So with the perspective view, I thought is actually when you see the shadow, I thought only it's 100 millimeter. So if you convert this, that is 10 centimeter. So if you see right away, if I move this closely here, bit, if I see the left side, I can see that it's actually quite tilted. It's not right away, because when I move that, it's actually quite tilted. You can see right that it is quite tilted here. It's not that. So small angle changes there. So if you move the top portion, you can see that it's slightly above 100. So what we can say is that it's actually 1 point, or we can say that it's actually 1.1 or 110 millimeter, nearly approximately. So when you are going to design that Morse key, you should know that my dimension of this one is 11 centimeter. So if you are building a base which is actually only 8 centimeter, this won't be appropriate, because you are going to make a contact point here. So if you do that, you can see that it is slightly above 7.5. So with this software, you will be able to calculate the dimension of your STL files which you are already download from the net. So what you can do is that you can either scale it. You can see the scale option here. If you click that particular icon, you can scale that option here. You can have a lot of options where you can just click it and you can scale it. Scale it means when you click it, an arrow appears, and if you make this, it will make bigger, and if you make this, it will be make smaller. So this is how you can change the 3D printing structure that you have uh, accordingly for your project. I hope it was quite useful. This is a basic thing that we can use this software. This is a thing. I hope this is more visible now. I will just repeat it again with another 3D printing model. So I will just delete it, or I will just move this to the side, and I will copy the base as well. Okay. So this is a top side where I have put my base as well. Okay. So let me. Okay, I will just, since it is standard, I will put this file again as well to have a comparison. Okay. So this is actually I've kept it side by side in this place. So you can see that we have already different holes as well. So if you know, these holes are also being matched. So what you should do is that what we will do is that we will print all these holes, and these holes we will use the screw, and we will have a connector here as well. This is actually a perfect match. So another thing is that if you are printing this model, you need to fix this plastic base over a wooden board. So if you have a wooden body which is match this size, then it's well and good. Otherwise, if you have a wooden body which is actually smaller than this size, what you can do is that you can scale it right away. So what you can do is that I hope it's visible, or if it's small, I will just zoom it right away. I hope it's full screen enough for you visibility. Okay, this I will put it here right here, and I will just align it here. Okay, perfect. So this is actually, we are placing this above this one. So if you have a wooden piece which is to be kept here, so I will just I have that diagram as well. We have already seen the 3D printed mouse. So if you need to place it here over the wooden body, which is actually quite smaller than this one. So using this 123D design, what you can do is that you can scale it. For doing that, you just click it. When you click it, a window appears here beneath it. You can see whether you can move. So the main properties will be visible, or you can scale it. So smart scale is that you can scale it with a particular section wise. So another that is another thing. So if you want to uniform scale, what you can do is the third option, scale option, where you can uniformly scale it. Suppose if you want to scale a factor which is actually smaller than this one, maybe half of that one, you can type 0.5, or if you want double the size, you can just type 2. So if it is 1, means the no changes happening. So if you can change uniformly, or you can change in non-uniform as well. If you change what is the X factor you have. So what I suggest is that If you have exact dimension, I prefer you to do this in this way, a non-uniform way, rather than moving your mouse. If you are comfortable with that, you can move the mouse in a such a way that its required dimension is met here and here. So with this, I hope you can modify your required 3D objects available from net according to your specific. I hope with this small session, I hope it's clear that you will be able to download STL file. I will see you. I will show in browser how to download STL file as well. But if you have an STL file, I hope it's clear that you can change that STL file to required 3D model required for implementing your small home brewing project. I hope if it's clear, then we will move on to Google Chrome, where how you can download those STL files for your projects. If it is that, then we will move forward to see how to download those STL files. If it's yes, we will proceed with that. Okay. So what I will do? What I will do is I will share my Chrome window. Let me see. So what I will do is that I will show it from my Google point of view. Whatever we do is that we will search Google, right? So I will just open an application which shows my Google. I hope you can see my Google page. Okay, it is not visible, I guess. I hope it is visible now because I can't see the software. Okay. So here what you can do is that what you can just search directly. What the file requires is STL files. STL files. So STL file is this is a STL file. So you can see that we can see the STL file download. So the main thing is we need to have STL files for hams. So ham radio. So this is actually the common search engine that we get. So this gives a general idea or the site where which you can browse all the STL files, 3D printing file for the ham radio. So another beauty of it is that you don't need to here if you see that you have a radio buttons here. So if I just check it. So in this session, what I will do is that I will just elaborately explain how to search Google to file your required STL file. So here I just got a file of ham radio buttons. So it's amateur radio 3D model for 3D file. So I'm just clicking a few examples as well. I hope when I switch over, I can, you are able to see the output as well, I guess. Okay. So these are the files that is there. So a few of them actually I'm not familiar with because I'm new to this ham radio and home brewing. Okay, so here we can see the ASO cable screw lock because it will be, you can see that 82 downloads are there. So another thing is that in Yagi element transfer where they can bend the coil as well. Mic adapter, I hope you are familiar with this as well. So if you download this thing, I can just click direct download and it directly downloads it software. So one thing I need to find is that mostly all 3D files will be available in Thingiverse. This is actually an open source platform where people share their 3D printing files. The other thing is that right away, directly saying this web page, if you are able to get the result as a particular web page, it is well and good. So we have other web pages as well, but this is actually the common thing that we, as a 3D printing engineer, we usually get is. So you can search many files as such in this web space, where you can search for the 3D printing components that is available for you. So these are the basic things they have already designed there. So these are the already components there as a overall crowd source. But if you in that chat window, if you want to see a particular 3D printing, suppose if you say that you are working on a homebrew of so and so, and you need to have a particular file, or we need to have a 3D printing model of a particular source, then I can show you in live like how to search to get that particular file. If you have such, you can just comment it in chat. Then I will have a live session of how to find that particular STL file and work on 123D and how to print that in Cura. So if you can just put it, then by the end of the session, we will have that as well. And I hope the session about searching an STL file and with the download of STL file, how to change the dimension according to your application. I hope these two things are clear, I guess. I hope you can try it out after the session. I hope this is clear. If yes, then we will move on to that software printing part where you are printing the 3D printer. We will use the 3D printing software. The software is Cura. So we will move on to that. So these are the things, the downloader things, but especially for ham radio, VH mount thing. So you can just try it and got the site. So having the knowledge of 3D printing and using it is actually quite efficient, because everything you can't get it in a flea market where each component cost is much higher, but you can directly do the 3D printing. So what we'll do is that we will move on to another software called Ultimaker. So I will share that file as well. So the software that we are going to use, the name is Ultimaker Cura. So Ultimaker Cura is a software developed for printing Ultimaker printers. Ultimaker, they produce 3D printers. So actually the standardized version is Ultimaker. Being an engineering college professor, like we have an Ultimaker 3D printer, and this Ultimaker 3D printer is available across the Fablab across India as well. So this is a standardized printer which supports heavy load duty. So to acquire a 3D printer, you can spend maybe 12,000 or maybe 25,000 to have your own Delta printer. So that precision of that one is quite low, but it does the job. Okay. So better thing is that to spend a 3D printer is actually quite not feasible for a particular person. So so what you can do is that the screen is not shared. Yes, I was talking in introduction before that. Okay, so this is actually the screen share. So this is actually a 3D printer. So you can see that it's actually I have customized this Ultimaker Cura for Ultimaker 3. So we have a different set of Ultimakers because since I am been using Ultimaker 3, I have set this Cura software for that one. So here, what you can see is that you have a right side window with a lot of features. One minute when you switch on, you can have that option. So if you see this one, I hope it is visible. And if you see the top side, I clicked settings where you can select the printer, and I have selected Ultimaker 3. So in order to do this one, you need to add printers. So if you have a different version, you can just click add, and you have a different set of printers that is made by Ultimaker. So the latest one is Ultimaker S5. So Ultimaker 3, I think it costs around 3 lakhs to 4 lakhs between that. And with the extra of 75,000, you can get Ultimaker 3 extended, where you get extra dimension of 10 centimeter. So that you have a 3D structure. Wherein Ultimaker 3 extended means you have an one X, Y, Z, one varying component Z, as its height is more than 10 centimeter, extra 10 centimeter you get that. So it costs nearly 75,000 plus with Ultimaker 3. So here we will today we will use this Ultimaker 3, where you use this software Cura for implementing this particular project. Let's say that we have already designed a STL file according to our dimension. Let's say that, or let's assume that we have already done that. So let me take that same Morse file. So I'm taking the Morse file, and which I have downloaded from my window. I will just click and drag that particular STL file onto the Ultimaker. So what it does is that it directly takes that particular image over here. So if I zoom it, so this is a thing similar to that of 123D. The controllers are the same. You can use right mouse key to rotate like this, and you can use the left key to select that particular thing, and you can see three axis came X and ZY axis with a beautiful RGB color diagram. So let's say that we have X as green, Y as red, and Z as blue. So what this does is that this Ultimaker does is that if you have already placed, then if it is yellow, it is ready to print. Suppose if I move with this axis, I'm moving to this axis and I'm keeping it outside the particular white area. So what it does, it is not identifying the object because the object placed here is actually out of the bound, meaning out of the 3D printing area where it doesn't identify the object to be printed. So if you want to print a lot of objects, what you do is that you place each object one by one. So suppose if I say that I want to print like maybe let's see, 1, 2, 3, maybe 4 I can keep with these. So what I'll do is that I will take the same file and I will put it again so that I can see the another file also comes here. So I have kept that as well. Since I have changed a little bit, I will use this axis alone so that each and every STL files are aligned in the same way. So I will place a lot of files. So if you want to have a Morse key mass produced, or for your 4 of your friends have asked you to 3D print your file. So you will visit your 3D printing center at Fablab only once maybe. So during that time, what you can do is that you can print these all ARM base for like this side. So for I told you like for easily sorry, we can place this 4 arms here. So if you see that we can see a small spaces behind as well. So I will just put it right away so that if possible I can keep one more 3D printing file in the front so that it will be helpful for me as well to print right away. So what I will do is that since I'm having 4 arms printed, I need to have a base as well. So what I will do is I've kept or copied the base, but you can see that since there is no place here, it went outside. So it is not able to, I'm not able to print it. So what I can do is that I can move it this way that it fits here. Okay, so I can rotate here. So here if I see that there is an option called rotate, where the axis being changed to circles. So we can move this according to the circles here. So if I move the blue thing, it moves to that particular axis, and you can see it has been rotated. So now I can move it inside of this. Okay, now. So now this also it takes the base of one can be kept here as well. So this is how you place the STL file components here. Now I hope placing accordingly. Hope it is till now it's okay for you all. I hope if it's okay, then we will move forward with the settings of the printer that we are shown in the right side. Okay, I hope it's clear, Chima. So let's move on. So here you already have placed the components, and you can just see that we have a lot of settings here, because such you feel confusion. But when you see each and everything, it will be quite easy. The another thing is that if I place all these components, the time required for me to print all these will be very high. So if I do that, if I just directly select materials, let me see. Let me see that the Extruder 1 and Extruder 2. We have two in this Ultimaker 3. It has a support of 2 extruder machines. Where extruder is a machine where it takes PLA and it converts that PLA to a liquid form through the extruder machine. I will show you a small video of it, which helps you to understand as well. So without any further settings, without default settings, I have I asked this Cura to prepare this 3D printing file model to be done. So it prepares it. So any 3D printing model can be placed here, and you can change the dimension. Even 3D files also can be placed here. This Cura software will convert any 3D files to SQL files. So if you see that, if you can, I can save this. I can save this all the settings here, and I can use this file to that. So what it does is that the SQL file we have used here will be converted to a G-code file. G-code file in the sense that GCODE. This is a G-code file, where G-code is a code given to the printer servo motors. It has servo motors which will enable the extruder to move in these three axes. So if the extruder moves in this axis, X and Y axis, one layer will be completed. And after one layer is completed, it will move a little bit top so that another layer can be produced. So then it will move X and Y again. So we have X and Y axis, which is printing all layers, and after one layer is completed, it will move up. So we can say that if we are talking in terms of these colors, we have R and red and green. So first, the red and green axis will be used to cover a particular layer, and then after that layer is over, when we will use the blue axis, it moves a little bit up. But we need to know how much it should go up so that the next layer is good. So that depends entirely on how you should map your printing profile. So if you see, you have a profile here which is very fine. So you can see is that each layer is of 0.1 millimeter. The point to be noted, ladies and gentlemen, is that the layer is very fine. It's not even 1 millimeter. It's a 1/10th of millimeter. So it's actually, if you see a millimeter in scale, that even that 1 millimeter is being divided into the 10 divisions. So you can see how fine it is. So if you see an extra fine option, it is being again divided into half, nearly half of that. So extra fine, if you print it extra fine, so if you increase the layer, definitely the time required to print all the files also will increase. But the beauty or the aesthetics of the particular design will be very beautiful. You can see very fine and refined, smooth printing. But the costs will be high because the time required will be more. So if I change, so usually what we do is that we use fine as a normal thing. Suppose if you are prototyping a particular 3D printing project, or you can use a normal version, and where you are finalizing the component, you can use extra fine. This is entirely up to you. So to give a brief overview, let me double this fine to fast. So instead of 0.1, what it will use that, it will use 0.2 millimeter. So if I'm putting fast, it was actually 13 hours. It will take 13 hours, and it will roughly use 62 grams of PLC. So naturally, you have 1,000 to 1,500 rupees for a 1 kilogram spool, where you have used only 62 grams. So I will tell you about the cost as well. So now we are going to prepare this file according. We have changed to double fast. Instead of 0.1, we have changed to 0.2. So let me see, and let me prepare it. So when I click there, you can see slicing process, because each 3D printing model will be sliced into each layers. So each layer, so now instead of 13 hours, it's drastically reduced to 5 hours. So within 5 hours, you can print it right away. So another thing is that printing 13 hours is quite high, and printing 5 hours is quite high. Since it is not an ordinary paper, it takes time to print. So overnight, it has to be printed. So we have different faculties, technical faculties over fab labs across India. So if you approach there, if you start printing, they will take care of it, and overnight the 3D printer will be operation. Usually they will use Ultimaker 3, where it supports good duty also. the duty because it's a commercial purpose. So you can rent it and you can do it. So within 5 hours, it will be spent. So speaking about cost, right? I will just explain that as well. I hope I'm audible enough. Okay. So here, if you see, we have 5 hours and 23 minutes. So how cost is applicable for 3D printer for any general case is that it will be rounded to the next hour. So 5 and 23 minutes. So it is rounded to 6 hours. So next thing is that 62 grams. We are using 62 grams, and what we will use it. They will add a few tolerance grams as well. So according to company specific and each their policies, they may add maybe 5 grams or 2 grams according to the wastage it requires. Because if you have a lot of printing, some of the material may be lost while using the extruder, because it works similarly that of glue gun. I hope everyone has used glue gun for their project where you stick on different surface using a glue gun. So when you start glue gun, when you place a glue gun in there vertically, due to the gravity and because of the heat produced, few of the glue material may drip down. So those are wastages. So similarly, while using extruder PLA, few of them it may be done as wastage. So as a wastage allowances, they may add 1 or 2 grams up to 5 grams, or even 10 grams. 10 grams is worst case. So with that, they will fix the rate according to the time and the gram. I hope it's clear as well. So most of the site, especially the Fab Labs, they have an online feature of booking the printing as well. So I will just show that one in the last slide, where how you can book the 3D printer and you can rent it for a couple of hours, and how they charge. So these things we will deliver. So this is an important thing, profiling. So our main aim is to balance this hours and the hours that is required for printing it. So accordingly, we can change the settings so that we have enough clarity as well as the product should be verified. The next thing is that this is about profiling, and next thing is if you see the quality, it's that is same as that of profile. Point. So this is both tied up. If I use extra fine here, if I say it see that it changes. So the profile and the layer height both are same. It shows the quality of the printed material that we have. I hope it's clear. And next thing is, if you see a 3D object, it is actually quite printed as if you see this is not entirely fully a solid block. It is actually a shell where we can fix the wall size of the shell. If you see, if I have a box placed over here, so I will just remove it. And if I place a small box here, let me see another file. I just delete this so that I can place assembled version of this. This is actually a small assembled version of the other two, where you can see this circle as well as this type of clamp. It's actually quite a 3D size. A small block size is there. But if you strictly speaking, when you are printing it, we won't print as 100 percentage full brick size. But we will print it in a shell size, where that the wall thickness can be made according to your wish. If you want, if you have a size, like say this is actually a size block of, let me quickly go to a 3D printing object software, because I will switch it over. Let me see. I hope you can see that. What I will do is that I will construct a small box here, and I will show you a 3D model of that. So if this is a box, and if you see that, uh, you can just maybe change all these things. But if you see that there may be some size here, it's a 3D block. So let's say that if it is actually a 3D block of size maybe 5 centimeter, 5 centimeter cube. So all are, this is 5, this is 5, and this is 5. So what we can do is that we can entirely fill this full cube with the 3D printing material, the whole. So it will be bulky and it uses more grams, but it's not advisable to use a full material to fill the body. So like construction of a building, we will have scaffoldings where we use different wooden rods for the painter as well as the worker to climb there. So what we will use is, similarly what we will have is we will print maybe a 2 millimeter thickness of wall, a big hollow box of 2 millimeter thickness, and inside that it will be entirely whole. But then you will ask, if we print it like that, if someone throws it, or if we push it, or if a pressure applies, it may be a chance of breaking it. So that is entirely true. To avoid that, what we will do is that we will with this 2 maybe 2 millimeter size thickness block, hollow block, what we will do is that we will have a crisscross connections as well. Some filling will be there, but mostly there will be there. So we call that in filling. So we can say that infilling percentage to be, if infilling percentage is 100, it means that we are filled the entire box with the material. But if you see, or if you say that infilling percentage is 50, it means that 50 percentage of which is filled and 50 is not filled. It doesn't mean that half of 50 is filled and half is remaining. It's not that. It is mixture of crisscross lines where it supports each structure. So that if you apply a pressure here, it will be distributed to the other section through a scaffolding kind of infusion here. So I will show this same thing in the 3D printing as well. So I will just show it right away. So I will just switch on to the Ultimaker. So I hope you can see here. So here you have that particular thing here, and I will just prepare it, and I say that this is a cell size of a few millimeter by default. And next thing I showed is infill. Infill means here you can see the crisscross structure which is available here. You can see a small diagram. I say it is 20%. So let me increase to maybe or 40 percentage infilling. So if infilling, we are increasing infilling, definitely number of layers which will be also will be high. So let me prepare it first. So already it was 5. Okay, it change to 9. To have it, I will make it fast. Okay, and shell is by default, and I will use maybe 20. And I will start prepare. So now it's slicing. Let's see. It takes 2 hours. So instead of, so I used fast and I reduced the shell size. So shell size I already used. So now from 13 hours, now it has been reduced to, it was reduced to 5 hours. Now it has been further reduced to 2 hours. But it serves a purpose. So if you see here, I'm changing to a layer view here. First thing is the solid view was there. So solid view shows how it appears when you print it. So I'm now changing to the layer view. You can see each layer. So if I click here, the show travels. It shows the extruder points where it, how it moves. You can see the path. So what I will do is that I will just try to play this. Okay. This is how, if I hope it, you can see it's moving. You can see, I guess. So this is how that final layer. So now you can see that the whole object. Uh, a bit as well. I hope it's clear now. I will make sure it's actually a quite 3D model where you can see in detail. I hope it's well, it's occupying your screen. So what I will do is that this whole thing has been divided into these many layers. You can see 137 layers. And if I take maybe 70th, 68th layer, 70th layer, you can see this is a structure of that particular 3D printing model. If I move it like this closely, you can see that the in-between spaces are there, but it has been connected with small kind of rods. So this is actually infill. You can see that here in this position it is not entirely visible here. It is actually a small hollow kind of thing is there. So only a structured connection is established between two structural points so that when you apply pressure it doesn't break up. So for 3D printing it doesn't require you to print in a such a way that you don't need 100 percentage of infill. You need only 20 percentage, which saves 80 percentage of your maybe material, and hence you can save money as well. So let me see how it happens. So first process is this process. So if I quickly increase that, this is how this extruder moves, how it prints. So this is how it prints each layer. So it is being fast at very points and only that point. So when it moves here, it is prints like that. I'm moving very fast here. It prints like this. It kind of covers this, and this is our first layer. This is how first layer prints. The next thing is that it will move one step up to have a second layer, and second layer is actually, if you see this fast, meaning 0.2 millimeter. So one the first may be there, and second layer is actually 0.2 millimeter addition. So there, if you see, the next second layer is being printed here. So if I move forward, it happens like this. It prints like this, then it finishes here, this finishes, and second layer is done. And then it moves an addition of another point uh, 2, it moves to the third layer, and let's see how it prints. This is how it gets printed. It prints. It moves like that. It prints it with all this fraction. Now it's 30 layer gel, and it comes up with there, and it's there. So let me see how it works. Also, this is how it prints. It prints that is particular. And if you see maybe 30, let us see the 131 as well. So this is how it prints as well. So let us see the circle area as well. So there it shows it prints a circle. Then you can see that it has been switched. The circle it is switched to the body part. So there is a slight jumping here. So I can show you this prints, and it directly jumps to there. So it is when it jumps there, it's actually the speed of travel. So next is we can also define the speed of travel here. And this is how it gets print, and you can see that there is a hollow in between. So we are used only 20% in filling to print that particular thing. So I hope this is clear as well. So this is how we print. The actual printing happens for like 2 hours. So in order to print this, the whole thing takes 2 hours. So you can save this file. If I click it, I can save this file, and I will get, if you can see, I hope you can see that I have converted that STL file to G code. So this G code, I will save this G code to the pen drive which is supplied by the Ultimaker. I will copy that this file to the pen drive, and we will connect to the Ultimaker. So it directly dictates the same file name that I have used. So it is a mandate that you use the same file. Why? Because if you have couple of G code files, you need to able to identify which you are going to print it. So if you don't remember, or if you give some numbers or like you won't be able to know the STL files you are going to print if you have a couple of STL files in your pen drive. So it's always better to use a file name to don't use space, you use underscore to instead of space to avoid further errors. So if you save this file is given directly to the printer to print. So I will repeat the three steps. First, you design a 3D model with .stl file, and with that ST file, you just put that particular STL file to the Cura software. If you are using Ultimaker, which is used by all the Fab Labs around India, with that Cura software, you will be able to save with the all specification. You will be able to save the G code required for the printer to understand the X, Y, Z axis of the stepper motor for printing that particular material. I hope with this session, I hope you are able to understand uh, how to maybe understand the basics of the 3D printing. If time permits, then we can continue with that. Otherwise, we will follow. Okay, we have UTSXA, the material used for UV resistance. I think UV resistant actually for outdoor purpose, it's not advisable to use 3D printing, because if you have a slight heat resistant, it is not advisable to use a PLA. So it is better to use ABS material, which is quite heat resistant. It goes up to 220 like heat. It needs more than 220 degree Charlie to heat up the material to melt even. So it can be used for 3D printing. So there we have a different set of 3D printer used for ABS printing. So naturally, for all 3D printing facilities, we commonly use this PLA, but we can use that ABS for doing that as well. So I hope we have covered the basic things of the 3D printing for, especially for hands. So if you have any further questions, I'll be happy to take it. So let me just quickly finish the PPT, remaining PPT as well, so that the materials that can be printed by the machine. I'm not sure what materials mean, the 3D printing materials or the materials required by the hand. I'm not sure. Could you specify that one? Meanwhile, I will finish my PPT as well. So this is actually thing that we have already seen in 3D printing parts, and this is a DNC. I hope you already are familiar with the diamond. And to have the dimension correct is actually a tedious task. But if you have a 3D printer and you can design this is well and good, you don't need to use carpentry work or any other work to do that. So the thing is that we have used here is Ultimaker, and I told here I have used with Ultimaker 3, not Ultimaker 3 extended, where you get an extra of 10 sorry, 10 centimeter, where you can see here, this is the size 215, 215, 200. But in extended, you have the same 215, 215, but you have 300 millimeter. Right? So that means that you can get additional that one. So you have to pay addition as well. So this is extended one. You can see Ultimaker 3 extended, and this is Ultimaker 3. So naturally, these two are the commonly available printers in industrial wise, where if you able to rent a particular thing, this is a basic thing. So as you said earlier, if you had asked a question, materials here. So this is actually the two materials, PLA material and ABS material. Commonly used is PLA, and rarely used is ABS. For any application, if you need more heat resistance object, if you are placed in sunlight, so it is better to have this ABS, acrylolite, bentonite, steelite. I'm not sure how to pronounce it. So polylactic acid is a commonly used material, but this material can be used to have a heat sensitive as well. I hope I have cleared your question. So just recap, the software I used is the AutoCAD 123D design, and printing software I used with along with the AutoCAD design is that Ultimaker Cura 3.0. This is the software used for Ultimaker 3D printers. So if I'm using a Canon or HP printer, I need to use a software which is compatible by the HP or the Canon printer. Similarly, if I'm using an Ultimaker printer, I need to use the proprietary software provided by the Ultimaker company, which is Cura 3.0. So these are the things. So since in Kerala we have a Fablab at Kerala, we can visit the site, and I hope other states have a similar kind of website here. So what I will do is I will quickly show the website as well, so that you will know how to operate the website and how to get access to the network. So I hope I have few questions as well. Okay, let me rewind it. Okay, materials, I've covered that. Okay. Okay. Yeah, yes, sir. U2 TNA. How environmental friendly precautions should be taken while printing. So, environmental friendly is that it's a plastic. So, obviously, we have banned plastics. But if you see the environment point of view, we are making sure that if you are implementing it, you are not implementing outside door where you'll be left open. Another thing is that if once you have printed that one, always you can't reuse that printed object, but you can reuse it for other purpose. So environment friendly, we can say that it's quite environment friendly, but it's always better to reuse it to other area where you can't use the same PLA for 3D printing again. So we can't use that. So I hope I have answered your question. The precaution that you are taking while printing is that you should be well familiar with the software, and you should know the do's and don'ts. Where I initially told that I have learned from my mistakes, where I have taken the SQL files from the net and I have directly printed that particular object, so which is not quite advisable. So that is my suggestion to you, you to TNA, and I hope I have answered your question. Next question is from Srejit. Materials that can be printed by the material. I hope I have ideas. Actually, raw materials, I'm not sure, because the commonly used 3D printer use two types of plastic, that is PLA and ABS. So we have different types of printer available in printer, where we use convex lenses and we use sand as a material for printing an object. I think that you can refer the video, like 3D printing using sand. So that is another thing. So it converts the solar rays, concentrated rays, using a convex mirror, and it prints through the focal point of that. That's one. It's in the advanced version of the 3D printers that we have, like 5-axis 3D printing, where you already have seen a plate, but the plate is not moving. So we have an extruder which moves X and Y, and this plate moves a bit down. The extruder doesn't move up and down, only the plate moves down. So when the plate moves down, the extruder is actually kind of up. So this is how it prints. So first layer is printing, so it plates move down, it prints and moves down. This is how it gets printed. So if you see this plate here, it moves only in one direction. So the extruder moves in X and Y direction, and the plate, the heated plate, moves in Z direction. So we have a 3D printer. But we have 5-axis printer, where the extruder moves in X and Y direction, and the plate moves in all directions. So we have 3 directions. So we can have 5-axis. So that is an advanced printer that we have. I think it's of 12 lakhs, I believe, and hope I'm correct. It's an advanced printer, is 5-axis printer available in additive manufacturing. So next question is achievable dimension tolerances. Actually, I have already told you while explaining Ultimaker printers, we have a certain dimension. I hope I have cleared as well. Okay, any service provider. Actually, in Technopark, we have Fablab. One of my close friends is Mr. Vinod is there, which takes care of Fablab. So yeah, I can always, if you connect me with over Lima Lima, I will give you the number of Mr. Vinod, where he can help you out with 3D printing as well. I hope I have cleared that as well. So we have Fablab Kerala, where you can run that as well. I will just shortly show you how to book the service as well, or you can directly call him. Or Lima Lima, I can give you the details. Okay, and meanwhile, I will show this one. Okay, so if you have any further questions, we'll move on. Yes, I will show my final slide. So it's a robot actually. So this, if you see that this is a thing I have made, I hope it's visible. All the red components here I've used is the 3D printing PLA material, and the black color is all servo. So I have used only in electronic components. I have used only servos, and all other parts shown here are all 3D printed. So that is the beauty of having a 3D printing session. So if you have that 3D printing, you can print anything that you require. So that is actually quite efficient. Yeah. I hope it's visible now. So if you see that I've used 3D printing, and I have used Additive Manufacturing to control each 8 servos, and I have developed a small PCB board where I have connected using a mobile cable. I have connected to the socket here, which delivers 4 ampere through my OnePlus phone. It delivers 4 ampere 5 volt 5 voltage. So that is required. I need 4 amperes to drive all 8 servos. My ordinary adapters won't work. So I used OnePlus adapter which delivers 4 ampere to all deliver all 8 servo motors. I have developed a board where I just insert my Arduino Mega board onto it. So it connects to the regular pin as well. So I can reuse the board as well. So that servo automation I already seen. So the best thing is that you can refer this YouTube channel where he talks beautifully about 3D printing related stuff. So you can refer this website for here. Anyway, I will share the PPT if you require. So you can always reach out to me. So this is my contact address. You can just scan this if you are in laptop or in this computer. You can just scan this right away, and you can just reach out to me. So I hope it's clear. So just I will type my phone number as well. So you can just reach out to me as well. So anyway, thank you all. So if you have any further questions, I will answer to that. Then after that, I will just make sure that you understand the usage of the Fablab here. You search that, and you can finish the session. If you have any questions, I am open for discussion. Any questions? Okay. Oh, yes, another question is that multicolor printing possible? Yes, multicolor printing is possible. I've shown you Ultimaker 3, where we have used two type of extruders. Extruder is the sense that we use PLA material for printing. So multicolor printing is possible. I have already shown if you load two different spools of different color and give it to one extruder and to another extruder, you can use multiple printer as well. So I use the Siemens Reader, so I can generate step energy as well. Are these compatible with Cura? Yes, you can convert. Best thing is that you can convert that file to STL file, because of commonly STL files, and that will also taken by the Cura. The Cura does is that it takes 3D printing files and it converts to the G-code file. Finally, what the printer wants is a G-code file. So all 3D files are compatible, but what I will recommend is that STL files, which is the first basic file that is internationally accepted one. So that is true. So anything else? Okay, then okay. Thank you, Faisal. I hope it was informative. Okay, thank you, Mohan, Matthew. Thank you, Rajesh, India. Thank you. I hope I've spent your valuable time for gaining a knowledge. And, thank you for SreeKumar for having me here. It was a quick notice, but I'm happy to take sessions. Let me conclude with a final note where how you can book a session at Fablab. So let me share my screen with that. Okay, suppose if you have a screen here, Fablab website, yes, okay, thank you, SreeKumar. Okay. I have hope it's visible here, Fablab here. So you can have training or download section activities here, projects here, a booking. So you can see a booking option. So this is actually Fablab Kerala. So I'm specifically talking about Fablab Kerala. It's very dynamic and it's very supportive. All the staff are very supportive, especially Vinod who is there. So he's actually Vinod. You can see. I hope I can change to the previous slide. So Vinod photo was there. I can show you as well. He's a quite nice person. He's a gentleman who actually. This is a site where you can just click book, and you can just book a machine here. They have different type of machines over there. You have CNC. So he's Vinod. So please confirm the booking location. Default location is Trivandrum. Okay, I checked Trivandrum. Or if you are in Kochi, you can check Kochi. So these are the equipments you have. Being a home brewer, you already have these type of equipments here. But if you go over there, you can have a soldering meter, multimeter, or thing. You can just book for next 1 hour, 10 rupees. And if you have a CNC machine, this is actually a wooden CNC machine where you can book that one as well. It's a mini CNC machine. This is actually not an additive manufacturing. It's a additive manufacturing. So here you can see the Ultimaker 2. They have only 2. In our college we have 3. So this is actually the common 3D printer that we use. And it's a vinyl plotter where you can even print the circuits required for etching as well. So you can see it's only 35 hours per hour is there. We can see that what we mainly ensure is that we change the settings in the Cura in such a way that we try to reduce number of hours. So if you use 1 hour and 1 minute, they always take as 3 hours. So it's better to have like near to rounding near to hour, like say 1 hour and 50 minutes or 1 hour and 56 minutes. So that is actually well and good. So we can use a maximum. So yeah, they have a laser cutting as well. So you can just click book, then they will charge accordingly there. So they have a nice quite setup over there. So you can just click book. I hope you can see that. Okay, I'm not sure in present scenario where you'll be able to book or not. See here, the slots available dates are here. See, you can see the time here available. You can just draw all the things required. If you have, let's see, upload the STL files. Also, it's always recommend to have a STL file. That's why I talked about STL files. Because in generally, when you're talking about 3D printing, that commonly accepted file is STL file. So it's always better to convert to STL files to have a better compatibility. So others also works, but if you see that if you have an alignment change in your Word document, we always prefer to convert to PDF and print, right? So it ensures the margin of that particular Word document. So as we convert Word document to PDF file to ensure the quality of the print and with the margin, so it's always better to convert to STL files for printing to Cura. I hope I have cleared that as well. So that same G-code can be given to SD card or to Ultimaker, and we can print that. So all steps are there, available are there. So you can just select a date. Suppose let's say I need to book a 30. Let's see. Okay, I can select this Trivandrum, and I selected maybe I will go by 5 p.m. So I selected that slot. So next day I can also save that. So once it starts, according to the files that we load, add to cart, then you can pay it right away. So you can just go to and directly contact him, and you can book the session as well. So this is how easy how makes the startup mission Fablab in Kerala, which helps us. So all Fablabs in the states have the same thing. So this is how we can book a machine and we can print. So you don't need to have a college nearby to entirely print that. If you have a college nearby, always you can use the resources as well. So we can go specific because the demand in the college compared to the Fablab Kerala doesn't have a less requirement. And if you are having any familiarity with them, they can do it for maybe with a lower cost than for Kerala. So it's up to you. So I hope it was very useful for you. So I hope it's clear. As I have selected this video has been recorded. I have recorded it, I guess. Maybe I can. I will, if I there, I have a YouTube channel as well. I will try to upload it as well because it has nearly 1 hour 40 minutes. I'm not sure, but I'll try. Science Technology Museum. Oh, it's available in. Thank you, SreeKumar. Okay. So I haven't used that one. So maybe we can have a session over there with their help. I hope you can arrange that also. So it will be helpful for our hands as well. So we can have a live demo of printing of our new components. So it will be useful for them. We have around 21 attendees, and thank you all for here. If any questions are there, okay, thank you, Abhijit. Happy to see you here. So thank you all. So if you have any questions, off to SreeKumar if you have any further announcement to make. I hope I've made your morning session informative. So if you have any queries, I'm standing by. Thank you, VO3 BOJ. Okay, thank you, SreeKumar. Happy to be here, and thanks again. So see you soon tomorrow. We have another session planned as well, I guess, SreeKumar. So thank you all. Thank you once again for this session. So hope to see you soon. Thank you all.